class, no matter what, no matter how detailed it might be, if you don't practice within yourself after the class, after you finish writing your exam, all these things will just be like an information and you tend to forget them very fast. So the first thing I want to beg you is that create time. You are going to create time to do two things. One, to reteach yourself, and two, to practice. The ability of you boosting that I know this topic is the ability to be able to teach, even if it is a 5-year-old baby, for you to be able to break it down for such baby, like, okay, this is what is this is what is this. And here is my uh, advice, or what I usually do, is that whenever I learn something new like that, I have an empty board. If I don't see somebody to talk to, I teach empty board just to explain the whole of the things that I felt that I understand about the class. So, and that will help me to remember. Because as a teacher, what makes you remember things is how often you teach it. And that will make you understand it more. Then as a student, what makes you remember things is how well you practice. And there's a reason why you need to practice as much as possible for every topic that you want to take in JAMB. There's need for you to practice question over and over. This is it. As a teacher, if I'm good, that I really want to spoil you, I want to make it look as if I've explained the whole of the bunch of this topic to you, I'll give you 40% knowledge. You see the remaining 60%, you are the one to search for it. And where are you going to find it? You find it when you are trying to solve problems. If I bombard you with questions in this class, there are still some questions somewhere that I have not touched. Is it that I don't know them? No, not because I don't know them. But you see, at that moment in time, I might not see them. It might not be appropriate for me to solve that kind of question with you at that moment in time. So, being a student, trying to get better, you will encounter those problems. And if you are able to solve them, it makes you better. Some problem will take you more than a day. Some will take you just a day. Some can take you months. It's fine. Just make sure you find solutions to them. In the process of you trying to find solution to each problems, what you are becoming in that process is what we are going to use to qualify you to be a brilliant student or not. So you see that everything still boils down to you. Now, if you pick a textbook, let's take for instance, you pick essential physics, another person pick new school physics, another person pick comprehensive physics. If you want to read the topic that we want to talk about today in those books, you are going to have different informations on that topic. Is it that the person that sits down and writes essential, is it that the person did not know the information? Is it that the person that sits down and writes what is it called, new school, is it that the person did not know what is inside essential? It's because sometimes the way we want to present our class, in order for the class to flow and to be beneficial, it is advisable to do away with some unnecessary details. Are you getting where I'm coming from now? It's better you do away with some unnecessary details, because trying to factor those details into your teaching will make the class become something more complicated. So that's why you will see that one textbook will talk about this, the other textbook will not talk about it. Because the manner of their presentation has to do with what they need to give. So if I come to this class that I want to present my class like I'm lecturing you guys, the way the details and things I'm going to talk about will be different from when I choose that I want to teach you. Do you understand where I'm coming from? So just because of the manner of presentation. Another thing that also determine the kind of information you get in every class is the level of the teacher's knowledge. I get it, and the readiness of the student, or let me say the level of the student. When I was in school, I took a course, Read Analysis 1. It's a mathematics course. When I did that course, it gets to a point, the lecturer says, pretend as if you understand. Are you getting that statement now? Just like the course is very like it's a very complex course that if you understand it very well, kudos to you. But you know the crazy thing about that topic is like quantum physics. Quantum physics, if you want to understand it, you know, when you get a book, you're supposed to start reading book from the very first page. But quantum physics is not like that. If you want to understand what is in the first page, you have to go and read the last page. You see that it's kind of abnormal. So when as you are advancing, that's what knowledge you become. It's become more abstract and abstract and abstract. So the same thing goes to this particular real analysis course. If you want to understand real analysis 1, you have to do real analysis 2. And you are doing real analysis 1 in your first year, sorry, your second year. And real analysis 2 is to be done in your last semester of your final year. And if you don't understand that in analysis 2, you cannot understand 1 the way you're supposed to. So the lecturer just needs to there's no way he wants to explain. Just pretend as if you understand so that we can move on. So until when we now start doing analysis 2, that's when I was like, oh, okay, so this is what this man was talking about then. Do you understand? So we now start getting to understand the whole of the things we talk about in read analysis 1. So that's to tell you that if you stop striving as a student, even if you have a good teacher, it might not change things that much. So you still need to read more, you need to practice more, give it all your time. I know there's a lot of factors there to affect you from studying, like you get tired, some parents are not encouraging, that's just the simple truth. And some parents are like them encouraging, pay for your lesson fee, give you time, buy books, like encourage you to do more, code you to get better. So some parents are not available for those things. And you have stupid friends, sorry for using that word. So friends that the whole of the thing they know is to just spend time on Facebook, like picture that doesn't concern them. All of those factors, amidst those factors, we need to find ourselves time to study, read, read and read and read until you don't need to read again. For example, now I have a senior colleague here that if you are dying in chemistry, like I can guarantee you, I can put my life in line that this man is going to resurrect you, that you get better in chemistry. And I'm going to drop his YouTube handle at the end of this class so that he can go there and still benefit more from it as well. It's a respected colleague, and we've been together for long. So, but if you as a person did not determine that I want to be good, and I'll tell you the reason why he's in this class, is somebody that cannot just bear it for teacher to be teaching rubbish. And I can tell you categorically that 90% of physics teachers that we have out there, they are not good. I'm not saying this to brag, but they don't understand that subject. And him being a chemistry teacher, and he has experienced what physics is even more enjoyable than chemistry. Why is these people teaching it like this? So in quest of that, he has always try as much as possible to invest time in learning physics often and often so that it can help people more. And I must tell you, we just need to help people. Serious. It's not about the money this time around. Josephine, the other time you were complaining, oh, this money is too much on a monthly basis. That money is not up to what we are doing seriously. And I must tell you, there are thousands of people out there collecting that huge money and they are not giving equivalent values. So please, I want to beg you guys, after this class, pick up your past questions, solve questions. Like, try as much as possible until you solve and solve and solve and you get to the one that you don't know. You have not learned. So I pray God will help us. So we try as much as possible to make the class relatable because sincerely, the topic we want to look at, I'm trying to share my screen now, and once you can see the screen, just let me know that you can see my screen. So can you guys see my screen now?
Yes, sir.
All right, thank you. So so the topic we want to look at, as important as this topic, the problem is that it's too abstract. Like, it's abstract that is quite boring. And the only thing that can make it interesting is if we can be talking about its application. Because obviously, there's not too much theoretical statement underneath. Most of things that is underneath are calculations. But you see all these calculations, there's no way you can do well with them if you don't understand the topic itself and some kind of terminologies that they use. So when they are using those terms, if you don't understand it to the fullest, the problem will still remain the same. So I want you to open your mind and pay attention to two things. Number one is to understand each of the formulas. And number two is to understand the terminologies that we are going to be using. You see, once you can understand those two things, it will help you a lot to handle questions under this topic. And I pray God will make the topic and the session a beneficial one. You just have to key JAMB. JAMB does not have choice. JAMB must obey. So we are starting with alternating current. Sorry. So alternate current. Now, when you talk about alternate current, before we discuss anything about alternate current, let's try to understand where all these things come from. Before we can have a current, we must have what we call charge. So from charge, which is denoted with letter Q, if this charge continue flowing, the time that takes this charge to what? To flow, that is the numbers of charge that you have per second, is what they refer to as current. If this is a charge now, and this charge starts moving out from one place to another, the time that takes that charge to move, are you getting it now? Per second is what we refer to as current. So, if that should be the case, we have current. If you now consider how we can generate current, you can generate charge by just picking a pen and then use it to rub your hair. If you do that continuously, as long as your hair is dry hair, you are going to generate charge. That is, this pen will acquire charge. Are you getting it now? So if this pen acquired charge, for that charge to flow, there's need for something else. Because if the charge did not flow, there will be nothing like current. Are you getting where I'm coming from now? Now, because of the sources that we use to power that particular charge, in order for the charge to what? To flow, we now have two different type of currents. We have one that when you use battery to power it, for example, let's say this is a circuit. If this is a circuit now, I think I need to clean this, sorry. So if this is a circuit and I decide to power this circuit with battery, this is a symbol for battery. When you have one long pole and one short pole, that's a battery, or you call it a cell. Here is positive terminal and here is negative terminal. Now, if this is what you have that you want to use to power this cable, this is just a wire. Whenever you see a line like this in an electric circuit, that line represents wire. So this is a wire now. And what do we have in a wire? A wire is a conductor. And when you have a conductor, what makes that thing a conductor is that, for example, if this is a solid now, I'm trying to explain different things there, so I want you to pay attention. If this is a solid can be divided into three. When I say explain solid according to their conductivity, you can divide them into three. You can have conductor, you can have a solid to be an insulator, or you have that solid to be a semiconductor. Now, if the solid is a conductor, what makes it a conductor? Before we talk about what makes it a conductor, for every solid, anything you call solid, they have three segments. They have the valency segment, they have the forbidden segment, and thirdly, they have conduction segment. Anything that you call solid, either it is conductor, insulator, semiconductor, whatever you want to call it, so long it is a solid, they have these three segments, or that you can call band, if you want to use the right term for it. They have three bands: valency band, forbidden band, and conduction band. So if it is a conductor, then it's going to have its valency band full of electrons. So as a conductor, it's going to have much electrons in this valency band. Then it's going to have a shrink forbidden band. That is, this forbidden band is going to be very shrink. Then it's going to have partial electron in its conduction band. So by the time you apply heat to these things, because anything that you plug to light or that you plug to battery, what happens is that battery converts what? Electrical energy into its energy. So once you apply that force to it, that electrical energy applied to it is going to convert it to what? Heat. So once it's converted to heat, that heat will make all this electron in this valency band, that heat will make them become energetic. That is, they will gain energy. When you are hungry, guys, you just do like this. But whatever they are telling you, you don't want to hear. Are you getting where I'm coming from? You are very weak. But by the time you eat like this, energy will come. You can run, you can shout. So the old people that disturb you when you are hungry, you can fight them now. The same thing is what happened to this what? Electron in the valency band. Once that electrical energy converted to its energy, what happened is that all these electrons here, they become energetic. When electrons become energetic, they start colliding with each other. As they start colliding with each other, because this conductor has a shrink forbidden band, they will be causing the forbidden band into the conduction band. And because there is now electron in the conduction band, that material will now be able to conduct electricity. But if the material is insulator, the condition is that the valency band is full of electron and the forbidden band is wide, while the conduction band is empty. So by the time you apply electrical energy into what? This particular solid, the electron in the valency band, what happens to them? They become energetic. As they become energetic, they want to continue, they fall into what? Forbidden band. So because the forbidden band is very, very large, they cannot cross it to what? To the conduction band. So because the conduction band is empty, we don't even know that electrons are moving. That's why, because we did not notice, because what will make us notice that electrons are moving is the fact that they are filling the conduction band. But now, the conduction band is not filled, but the electrons are moving as they are gaining heat. So since we don't see them in the conduction band, we conclude that what? Electrons are not moving. Because we say electrons are not moving, and that's the reason why we said what? Resistance is constant in an insulator. So that's why when somebody wants to define insulator for you, the person can say an insulator is a material whose resistance is constant. Are you getting where I'm coming from now? Or a conductor is a material whose the increase in what? Temperature causes what? Reduction in its what? Increase in its resistance. The higher the temperature, the higher the resistance for conductor. So because there is a large forbidden band, electron cannot get to the conduction band, and that material becomes what? Insulator. And for semiconductors, so what happened is that their valency band is partially filled, and they have little large forbidden bands, and their conduction band is also partially filled. So by the time they gain energy, that is, you apply electrical energy into it and that's converted to heat. So what will happen is that they have two conditions. They can choose to conduct, they can choose not to conduct. If that semiconductor is pure, what we refer to as intrinsic semiconductor, what will happen is that it's not going to conduct electricity. Because you will have what? Equal amount of electron in the valency band and in the conduction band, making it appearing like what? This is constant. You know, it's partially filled from beginning. If you now want this to conduct, you have to what? Add an impurity to it. When you add an impurity to it, it becomes extrinsic semiconductor. By the time you apply it to it, it becomes what? It becomes a conductor that it will not be able to conduct. But instead of an increase in heat to make the resistance to also increase, the increase in heat will now make the resistance to decrease. And that's why you hear your teacher telling you that what? Semiconductors are negative resistance coefficients, while conductors are positive resistance coefficients. So what do they mean by that statement is that when you increase temperature, resistance increase in conductor. When you increase temperature, resistance decrease in semiconductors. So if I now call wire a conductor, we are back to this place now. If I call wire a conductor, the way the charges inside that conductor, the way they are going to move has to do with the kind of what? Electric power that I apply to that conductor. And when you talk about this electric power, if you use what? Cell, that is battery, the kind of current that is going to produce will make the electron to start moving from this negative pole. Then this is electron moving from this negative pole, moving like this, down to where? Down to the positive pole. Now, you will agree with me that a bent wire is also a straight wire. so that you get what I'm saying. This is a straight wire, right? If I bend it like this now, you see now the wire is bent now. You can see. If I bend this one also from here like this, you see the wire is bent as well. So a bent wire is also what? A straight wire. So I can decide to stretch it. So if I stretch it, you get to see that all these electrons, they are actually moving on a straight line. So because all these electrons are moving on a straight line, that is the what? The charges are moving on a straight line. Any kind of flow of charges like that, it means that what you use to power that particular, or the kind of current that you can call that kind of flow, is what they call DC. That is direct current, because those charges are flowing in a straight line. Please, are you guys getting this?
Yes, sir.
That's what they call DC current. That's autology. That's what they call direct current, or you call it what? DC. Now, if I plot a graph of current against time, so if I plot the graph of current against time, I'm going to have, this is current I, and this is what? Time t. So I will have a straight line like this.
Sir. Okay.
I'm with you.
No, I wanted to say I could not see your screen, but I can see it now.
Okay. So this is what? This particular graph now, the graph of current against time that you have here right now, shows that this is what? A direct current. Now, when you talk about this direct current, if you want to use this to power your house, then you need to have more money. Like, if you want to use DC to power your appliances, you need to have more money. And I'll tell you why you need to have more money in order for you to use DC to power things. It's because the kind of material that you can use in a DC is resistance. That is resistor. And this resistor, what it does is that it doesn't save energy. Resistor does not save energy. Any energy that pass through a resistor will convert it to heat. So for that reason, there is nothing that is generating internal voltage. So it is whatever voltage that you apply that is going to determine the current you are going to get. There's nothing increasing the voltage. So, and that's why from Ohm's law, when you plot the graph of what? Voltage against current, you have what? A straight line. Sorry, I'm trying to let my line to be very straight. I see it now. So if you have V against I, you have a straight line. Why? Because current, whatever voltage you apply to a particular conductor is the amount of current that you are going to get. Nothing is generating more voltage inside it. So there are now thousands of appliances in your house that it's not just reasonable buying battery to power those things. That now make us have a generating plant. Generating plant, to make it simple, we have generator. If you are comparing inverter and generator, the difference is clear. The fact that inverter will not make noise does not make it better than generator. Generator is economical, and then the kind of light it's going to give you is, I can tell you, it's more reliable than that of inverter. So where they are generating our light from, that is the NEPA light we are using, where they are generating it from, let's call that place a generator. So that place, that generator that they are using to generate light, the first light that we talk about here is from cell. But this one that we want to talk about now is from generator. What happened there is that when you on your generator to give you light, it oscillates. That is, those electrons, instead of them to move on a straight line like they does when you use DC, what happens is that the generator just causes them to vibrate. Are you getting this now? They only vibrate. So as they are vibrating, when something is vibrating, we said it is what? Oscillating. So we have this kind of a diagram. So let's say we have this now. And here are the electrons. If this is a conductor now, here are the electrons. So what happened by the time you power this generator, all these electrons will start vibrating. So when they start vibrating, they are colliding with each other 60 times in 1 second. So when they collide with each other 60 times in 1 second, that means their frequency is 60 hertz. And that's how you see that your electrical appliance are always rated in 60 hertz. And we're still going to talk about how that affects the kind of current you get. That's secondary. But let's just take it now that basically they oscillate 60 times every second. So by the time you want to plot the graph of the way they are moving, if you want to plot it against time, just like we did for this one, what you are going to be having is this. If I have this to be current, I think I need to redraw this so that we can use it for long. This is current I, and this is negative I naught. That is the maximum current, and this is the minimum current. So by the time you plot the graph, you'll be having something like this. So this represents what? Time. Now, this graph here is not a straight graph. And we have it to be a curved graph like this just because the body is oscillating. So for every 1 second, it completes what? 1 cycles. That is, for every what? 1 second, there is what? 60 hertz, which is 60 numbers of cycles in 1 second. So that's what we have here now. Now watch. If this is the flow of the current, is not straight. You have this one to be positive, you have this one to be what? Negative. That is, they are the same thing, but they appear on the opposite sides of this graph. That makes them to be an alternate. So this and this are equal, but they are alternates to each other. This one is negative what? I naught, and this one is positive I naught. And that's that kind of current that flow in this manner is what we refer to as what? AC current. Not the AC, that is alternate current, which is what we want to talk about. So it is called alternate current because the charges are doing what? Vibrating. They are oscillating. And that one is called what? Direct current because the charges just move straight on a line. Do we understand this now?
Yes, sir.
So another person, please.
Yeah. Yes,
Okay.
sir.
All right. Now, there's something you should note about this current is that whenever the current, when I say this is alternate current AC, whenever the current gets to the maximum, whenever the current gets to the maximum, what will happen is that it starts decreasing. And whenever the current gets to the minimum, what will happen is that it starts increasing. So it's not stable. Alternate current is not a stable current. It's fluctuating. For that reason, it is not good for your appliances. Then we're going to talk about that. But before we talk about that, let's talk about the voltage and current produced by this kind of generator. Are we together now? So
Yes, sir.
we are starting with equations now. So permit me to clean this so that you can understand everything that we want to talk about here as far as the equation is concerned. So I believe everybody understand what they call the alternate currents now and direct currents. You've seen the difference between them, right?
Yes, sir. Yes, sir.
All right. So at the top here, I have I naught, and here I have
Yes, sir.
negative I naught. I'm with you.
I'm sorry to cut you short.
All right. I'm listening.
Please, sir, I want to ask the alternating current. Is it that all generating plants they generate alternating current?
Yes. The only thing that generates direct current
Okay.
is battery.
Okay, sir.
Yeah. However, if I get where you are trying to drive at, alternate current can be converted to direct current. And that's what happened in your appliances. They will take in alternate current. When they take in alternate current, for them to be used, they will need to be converted to what? Direct current. Because if they are not converted to direct current, your appliance will have issue. Let's take for instance that the current needed by your, the kind of voltage needed by your appliance is 220 volts. That's the maximum. And the minimum is negative 220 volts. If your appliance is using alternate current directly, what will happen is that your appliance will be going off and on. Do you understand what I mean now? Because by
Yes, sir.
default, if the voltage increase to 220, what will happen after that? We said it earlier that alternate current will start reducing when it gets to its peak. And when it gets to its
Yes.
what? Minimum, what will happen to it? It starts increasing back.
It will improve.
So if you are using, if your appliance are using direct what? Direct alternate current, what will happen is that you will have a pulsating current. It will be off and on, off and on, off and on. And you don't even need anybody to tell you that you not take time before you go and buy another TV. So we talk more about that, and we can just brief it in this class because the scope of this class cannot explain everything about the conversion of AC to DC, but we are going to just mention it a bit so that we have an idea of how it happens. So if you plot the graph of current against time, it's the same thing as plotting the graph of voltage against time. Now these are sinusoidal graph. And what are the graphs that they call sinusoidal mathematically? Any graph, either cos or sine graph, they are called sinusoidal graph. You can see that this one is starting from 0. If it is a cos graph, you will have it like this. If it is cos, instead of it to start from the origin, it's going to start from 1. Have you seen the difference now? This one is starting
Yes,
from
sir.
here, and this one is starting from the origin. Why? It's because the cos of 0 is 1, but sine of 0 is 0. That's why this one is starting from this point, and this one is starting from the origin. So if I decide to adjust this line, this straight line, instead of me putting it here, if I come to put it here, this graph from here to this place is going to be the same thing as from here to this place. Do you guys agree with me?
Yes, sir.
So that's why we call both sine and cos graphs sinusoidal. So if somebody can give you an alternate current in terms of a cos graph or give you in terms of a sine graph, but oftentimes it usually comes in terms of a sine graph, but no rules. Nobody tells you that it cannot come in terms of cos graph. And of course, if I want to test you how far you understand it, I will not give you problem in terms of a sine graph. I'll give you a problem in terms of a cos graph and see how well you understand it. Of course, it's still the same thing. Do you understand that now? Now,
Yes, sir.
there's now something I want you to understand and get clear as far as this is concerned. So if I have this graph, now I want to use this graph to derive some of the equations that we're going to start with. Let's take, for instance, that I want to know the current at every point in time. You know that at this point, where this one is the peak current, I want to know the value of the current in this place. What will be the value of the current here? What will be the value of the current here? What will be the value of the current here? What will be the value of the current here? What will be the value of the current here? What will be the value of the current here? I don't know, maybe you understand what I'm saying now.
Yes, sir.
Yeah, I want to know the value of current at every point in time. For me to know the value of current at every point in time, that's the reason I want to derive this equation. Do you understand where I'm coming from? For example, now I just come into the class and I told you that, oh, Emmanuel, if you are given a current with frequency of 60 hertz and the peak value of that particular current is, let's say, 5 amps, calculate the current when the graph is on 5 seconds, if the total time is so amount. That means I want to know, let's take for instance that this particular body gets this peak value at 1 second. If I want to know what the value of the current to be at 0.5 seconds, how do I get it? Because you know that it takes time for the current to get to the peak. And when the current gets to the peak, it will start reducing back. When the current gets to the minimum, it will start increasing back. So now let's now take for instance that the current is still increasing at 0.5, but we want to know the value that it gets to when it is 0.5, because you know that by the time it gets to 1 second, it is peak. So what will now be the value of current at 0.5? Or what will be the value of current at 0.75? Or what will be the value of current at 0.2? Do you understand where I'm coming from now? So that's what we want to look into. We want to derive a formula that can be used to calculate for current at every particular point. So how do we go about that? Let's see. Recall, if you pick up your calculator now, if you pick up your calculator and then you start pressing the value for sine, pick any value. You can pick from 0 to 360 or pick from 0 to anything. You will see that the highest value of sine or cos is not more than 1. I'm talking about in degree. The highest value you can have for sine and cos is 1. Is either it is 1 or it is minus 1. I want you to understand that. So if that should be the case, that simply means that both sine and cos, they lies between -1 So I'll say this is sine of omega t. Sine of omega t lies between -1 and +1. The same thing goes to cos. Cos of omega t lies between -1 and +1. Remember, omega t is like what? It's like an angle, theta. But why are we using omega t here? This is it here. Are we there, guys?
Sir.
Emmanuel, I want you to contribute in this class. Don't just be doing something else. Or mute your mic, be in a silent place. When I ask questions, talk. That's why it is a live class. Pay attention to this. I don't want you to cram anything. I want you to understand them. Where do I get this omega t from? Normally, what I was saying is that for sine theta, the value of sine theta lies between -1 and 1. But now I replace this theta with omega t. Why do I do that? This is the reason why. Alternate currents move in a circular manner. Because if you look at this now, this is an half circle. This is another half circle. Half circle plus half circle will give you what? A full circle. So instead of moving on a straight line, it's moving on a circle. And when the body is moving on a circle like this, it's moving with an angular velocity. And from circular motion, angular velocity is equal to what? Theta over t. That is, angular velocity is the rate at which the angle change per second. So if I cross multiply, I will have that theta is equal to what? Omega t. So if theta is now omega t, instead of me to have theta here, I replace it with what? Omega t. I hope you understand where that comes from now.
Yes, sir.
Good. If that should not be the case, I can rewrite the equation for current. Since current is on the vertical axis, normally, if you plot a cosine graph, y will be on the vertical and then x will be on the horizontal. Are you getting it now? So by the time you look for the slope of this graph, you'll be having what? Y over x is equal to what? Slope. So for this slope now, slope is equals to the sine of theta. Are you seeing it now? So that means y is equal, y over, I don't know why my pen is doing this morning. That means y divided by x is equal to, I want you to understand this, that's why I'm breaking everything down like this, is equal to sine of theta. So if I cross multiply, I will have y to be x sine of theta. Have you seen that now? If y is equal to
Yes,
x
sir.
sine of theta, that's to tell you that, okay, this is the horizontal axis and this is what? The vertical axis. Are you getting where I'm coming from now? Now,
Yes, sir.
as x is increasing, the value of y is being determined by the value of x. Am I making sense now? So
Yes.
instead of me to put or let me do it like this. Now, I want to know the value of y when the value of x is given. So that's what? Y equal x sine of what? Theta. So if y is equals to x sine of theta, then what I want to do now is I'll replace this theta with omega t. We know why it is like that, right? And this
Yes, sir.
x value, if the value of theta is 90 degree, y is said to be what? X. Abi? If the value of
Yes,
theta
sir.
is maybe 30 degree, y is equal to x times 0.5. Are you seeing that now? And so on like that. So that means if I get a peak value if I get a peak value of sine theta, my result is going to equal to what? X. So if that should be the case, I can write the general equation that we are looking at as this. Instantaneous current, that is current at every point in time I, is equal to I naught sine omega t. That's the current. So I now is equal to I naught sine into bracket 2 pi f t, where omega is equal to 2 pi f. Do you guys understand this now?
Yes, sir.
I believe you remember that omega is 2 pi f. Do you know how we come about that?
Yes.
Okay. So if that should be the case, I can call this equation 1. I is instantaneous current. And you have what? I naught is the peak current. And omega is angular frequency. Do you understand each of the parameters now? Now,
Sorry. I naught is what?
I naught is peak current, peak.
Okay, sir.
Yeah, peak current. Shall we go on?
Yes, sir.
Okay. So if I naught, if I, which is instantaneous current, is equal to what? I naught sine into brackets 2 ft, 2 pi ft. So the same thing goes to the voltage. If I want to know the voltage at every point in time, that is instantaneous voltage, will now become V naught sine into bracket omega t, or you can write it as V equal V naught sine into bracket 2 pi ft. Do we get this now? Where V is
Yes.
instantaneous voltage. Instantaneous voltage. And V naught is peak voltage. Do we get this now?
Yes, sir.
Okay. So whenever you are looking for current at every particular point, your result is going to be what? I equal I naught sine omega t. And if you are looking for voltage at any particular point, your result is V equal V naught sine omega t. Do we get that now? So any question?
Yes, sir.
Any question? Is that clear?
Yes, sir.
Mr. Dekpegba, do you have a question, please?
It's clear. It's clear. It's
All right,
clear.
thank you, sir. All right, so let's move to power now. We have understand the current and voltage now, so let's move to power. Now, power in AC. Now, when you talk about power in AC, you are talking about what NEPA are charging us. Because I have light now, and at the end of the month, NEPA will bring bill. Okay, yes. The class is recording. I have money, I'm using light. By default, at the end of the month, NEPA will bring bill. When NEPA bring bill, I need to pay. Am I making sense now? So, how do they calculate my bill?
Yes.
How do they calculate my bill? Which current are they using to calculate my bill? Or which voltage are they using to calculate my bill? Let's see how it goes. Let's plot the graph of current. And I want us to understand this very well. It's very important. So if this is I naught, and this is negative I naught, so this is time t in second. Now, if these NEPA people decided to use the currents that I'm using at this time, that is at I naught, if they decided to use this to calculate what I'm going to be paying, that means they are charging me I. And of course, it's not as if this is the current that I'm having throughout the day. I don't know if anybody is getting me now, because it's the only time I have,
Yes, sir.
because the only time that I use this amount of current, the only time I use this amount of current is when the time is what? Ts. Anything that this time is not here like this, I'm using below this amount. So if NEPA decided
Okay.
that what we are going to use to calculate your money is this I naught, are they cheating me or not?
They are.
They are cheating me, right?
They are now.
Yeah.
Yes.
Because I'm not using this particular current steadily. I only have
Yes.
it once in a while. And that's what you are going to use to calculate for the whole of the light that I use. So if I complain about that, then somebody that now like is very nice among them now say, oh, what Mr. Toib is saying is true. Don't let us charge him with that. Let's be charging him with this. So if NEPA start charging me this, is it in their favor or in their loss?
In their loss.
In their loss, Abi. Because
Yes.
this is the minimum light that I'm using. And this minimum light that I'm using, I only use it once in a while. Abi?
Yes.
Now, what are we not going to do now? We need to collect our money now. Okay. Instead of us to use either this one to charge you or to use this one to charge you, let us be using the average to charge. So if they want to use the average, that means negative I naught plus I naught divided by 2. That will be the average they are going to use, isn't it?
Yes.
Now, negative I naught plus I naught, that will give us 0. And that will be 0 divided by 2. 0 divided by 2 is what? 0.
No.
That means if they want to be using average to charge me, that means they will not collect money at all.
Yes.
Now, how will they charge? And why do we have this problem? Now, the reason why we have this problem is because your electronics did not use AC lights directly. There are some appliances that are inside your electronics that always convert the AC current to what? To DC. That is, this current that is moving like this.
Okay.
They already put those devices inside all your electronics so that the current will move like this. A current that is moving in a sloping manner like this, those materials that are inside your what? Appliances, what those materials does is that they convert this, because at first you have capacitor. Capacitor is used to
Yes.
convert AC to DC. Are you getting me
Yes.
now? So when they use capacitor to convert
Yes,
AC
sir.
to DC, instead of this thing to be full wave like this, capacitor will convert it to what? Half wave.
Okay.
Are you seeing it now?
Okay.
You see that
Yes.
this one is not also straight, Abi. But
Yes.
if you agree with me, it's better than this one.
Yes.
Now, this one is not still good for your own what? For your own appliance as well, because this one is still fluctuating, but the rate at which it fluctuates is not as much as that of this. But you see that everything that is negative, it has already cancelled it out.
Yes.
So what can we do now to make everything here to be straight? So that means for us to make everything here to be a straight line, let's just do some magic by using this cleaner. Can you see? But
Yes.
everything will now be smooth, but they will be on the positive side. But their value is not as high as the peak value. Are you getting me now? So because of those devices that you now have that are converting AC to DC and then smoothing it,
Yes, sir.
that's the reason why you cannot be charged using what? The peak value. Because if it is capacitor conversion, you will still be charged with the peak value. Are you getting it now? But because of other
Yes.
devices that we don't want to go into them now, because of those devices that will smoothen this thing, that means you need to pay lesser than the peak value, but you have to pay. So what do we do? What we're now going to do is to find the root mean square. So the root mean square value is what we are now going to use to find the amount that you are going to pay. So let's look into that now. Now, we have that power from Ohm's law, that is, recall that DC power is given as, is given as P equal I square times what? Resistance. That is current times resistance. Are you following now?
Yes, sir.
If you are to take it to AC, you will have I naught sine omega t all square times R. Do you know where this I naught come from?
No.
This I that you have here is an instantaneous current.
Okay. Yes.
And you know that
Yes, sir.
instantaneous current is equal to I naught sine omega t. So we are using that to
Yes.
replace this. That's why we have this equation now. Are we together now? Now,
Yes,
note,
sir.
note that peak current is equal to plus or minus I naught. Because when you talk about the peak value of the current, it can either be what? Negative what? I naught, or to be I naught. That's why we have plus or minus. But either of the way, your power must be positive. Are you following now?
Yes, sir.
All right. So if power is going to be positive, then we now need to find the root mean current. So, sorry. So this is called root mean square current. So for you to get the root mean square current, what it means is that we are going to pick our current. So when you pick your current like this, that is your peak current, when you square it, you are going to be adding it at every point in time, plus, if you pick this one also, are you seeing it now?
Yeah.
Then everything divided by 2. So in this case now, I
Okay.
can just have this to become I arrow ms is equal to the square root of I square all over 2. Are you seeing it now? Are you getting this? So we have root mean square current to be I naught all over square root of 2. Sorry, I'm running out of space, so let me find another place to put this. I naught all over root 2. So do we get this now? So this is what we call root mean square current. Hello, are we together?
Yeah, yeah.
All right. Now, as you have the root mean square current, we also have root mean square voltage. So that is, we are going to have V root mean square to equal to V naught all over root 2. So, because virtually their formula is the same thing, so to just save our time, we just know they are still going to give us what the same thing. Now, this is going to be the voltage that we are going to use to calculate for the average power. That is the kind of power that they can use to charge us now. So this is what we can use for it. So power, what we refer to as average power, is now going to be what? Root mean square current times root mean square voltage. Now, what's the significance of this root mean square? There's something we should know about it. So I'll call this equation 3. Now, when they talk about root mean square, what is another name for this thing? Or what does it really mean? You know, we talk about converting AC to DC, then smoothing it so that everything can be on a straight line, just like what? DC current. So by the time you smoothing from AC, that is, if I have something like this, if this is AC, by the time I'm going to finish, let's say this is current, by the time I'm going to what? Convert this one to DC, it means that this graph will become like this. So that you get what I'm trying to explain here better. Because we need to get this clear. This is where JAMB become tricky. This is an alternate current. I see it now. This is current, peak current, and this is time. By the time you convert this alternate current, that is AC, by the time you convert it to DC, so this is time, this is current I. It's no longer a peak current again now, because it's now DC. You see this I that you have here is what we refer to as the root mean square. That is the current I that you are going to have after the AC has been converted to DC is what they call root mean square. So if JAMB want to now ask you question, instead of JAMB to ask you to calculate for root mean square, they know it's so direct. You will get the logic. JAMB will now say calculate for the DC equivalent current, or calculate for the DC equivalent voltage. I don't know if you are getting me. Somebody is not getting this thing. So, if they ask you to calculate for DC equivalent voltage, or they ask you to calculate for DC equivalent current, just know that what the examiner is asking you to calculate for is the root mean square. So that's just that. So let's take a look at a quick summary. So in summary, we have been able to determine the formula for instantaneous voltage, and that is V naught sine into omega t, or V equal V naught sine into 2 pi ft. We have that instantaneous current I is equal to I naught sine omega t, or instantaneous current I is equal to I naught sine 2 pi ft. We also have that the root mean current, root mean square current, is equal to I naught all over root 2, or 1 over 2, sorry, 1 over root 2 times I naught. Also, we have the root mean square voltage to be V naught all over root 2, or 1 over root 2 times V naught. And we also have that power from AC is equal to I square R, which is in turn equal to I naught sine omega t all square times R. And we have that average power is equal to root mean square current times root mean square voltage. So if we want to like now calculate, let's now take for instance that the question is kind of tricky and you want to calculate for this average power in terms of the peak current or in terms of the peak voltage. So we can just from here and make I naught the subject of the formula. So when you cross multiply, you have that I naught is equal to root 2 times I root mean square, or let me just put the I root mean square first, times root 2. And you have that your V naught is also the same thing as V root mean square times root 2. Therefore, your average power can then be this multiplied by this now. So that means okay, which math am I doing here? Okay, no, sorry, I think I've gotten something wrong. So what I want to do is that I want to solve for this one in terms of the root mean square. So I don't even need to do all these ones before, sorry. So I have that this is equal to, since the root mean square current is given as I naught over root 2 times the root mean square voltage, that will be V naught over root 2. So that will just be I naught V naught all over 2. So you can use this to get your average power. And this is just the summary of the whole of the equations that we just get now for the first part of this class. So let's take some questions on it. Are you taking it down?
Yes, sir.
Okay, so quickly take it down, and I think you understand what each of the terminology, each of the parameters mean. So we have our V to be instantaneous.
Yes, sir. And the I too.
Yeah, the V is instantaneous voltage. The I is instantaneous current rather. And we have this to be,
I
you said you were offline before. The root means square
Yes, my
current.
phone went off. I quickly went on the gen.
Okay. The root mean square current is also called DC equivalent current,
Okay, sir.
because examiner can ask you that find the DC equivalent current. They give you AC current, and for your information, this is AC signal. When you see this signal,
Okay.
it means it's
Yes,
AC.
sir.
When you see this signal, it means is what? DC. This is a cell battery. This is an alternate current. So they can give you an alternate current and they will ask you to find the what? The DC equivalent. That is, what is the equivalent of that AC value in DC? So that's what they call the root mean square value.
Okay, sir.
So for V root mean square also, it is what? DC equivalent voltage. And R is resistance. I hope you understand all of that now.
Yes, sir.
Quickly take it down and let's look at some few questions before we move on to other part of the class, because the topic is a bit voluminous and I just want us to understand everything. So if you are done with writing, let me know so that I can clean.
Okay, sir.
So can I clean now?
Yes, sir.
All right. So example one, suppose suppose a certain suppose a certain household suppose a certain household device uses a voltage uses a voltage lines of 120 volts and require and an average requires an average of 200 watts. A, calculates the peak current calculate the peak current it uses and the resistance it produces and the resistance it produces. The resistance it produces. And B, calculate the power calculate the power if the voltage was doubled. Assume resistance is constant. Assume resistance is constant. Now, can we go on into solving the question now? Now, when you are told that suppose a certain household, when you want to attempt physics questions, how do you attempt it?
Yes, sir.
Because you have just 1 minute to answer this question as fast as possible. Read to yourself very fast to get idea of what the question is talking about. Then secondly is to write out what you have from the questions. By writing out what you have from the questions, it will guide you to know the formula to use. Because there is a lot of formula. Are you getting this now? So you have to know the
Yes,
right
sir.
one to use. So if that should be the case, what I'm going to do is that I'll first of all read. Suppose a certain household device uses a voltage lines of 120 volts and requires an average of 200 watts. Calculate the peak current. So that means I've read and understand this now. I will now read again. Suppose a certain household devices uses a voltage lines of 120 volts. So that means voltage
Is equals to 120.
is equals to what? 120. Now,
120.
this voltage that you have here, is it what? Is it a peak voltage or a root mean square voltage? I'm
It's
asking.
a peak voltage.
Is a peak voltage?
So I'm not sure.
Okay. Now, if it is a peak voltage, the question will mention it. Are you getting me now? But
Okay,
if
sir.
you look from the question says household devices uses a voltage. So when they say household devices, it means when AC current is converted to DC, the amount of voltage is using, and that amount of voltage that is using as at that time is what? DC equivalent voltage. That means that voltage is a root mean square.
Okay.
Do you understand how we get that? It's a root mean square voltage now.
Yes, sir.
Okay. So what's requires an average of what? 200 watts. The power is 200 watts. So what they ask us to calculate? Calculate the peak current, even if you don't know this one, because they have asked you to calculate for the peak current. You should have known that this one is what? A root mean square voltage. So we are looking for
Yes.
the peak current now, and what? Resistance. So these are what we are looking for. So we have power, we have root mean square voltage, and we are looking for this. So the question we have to ask ourselves is, what is the relationship between all these parameters? So we have that power is equal to root mean square current times root mean square voltage. Are you getting this now?
Yes, sir.
So if this should be the case, that means you have we have root mean square voltage. So come down to this place now. So that means the power, which is 200 watts, is equal to our root mean square current. We don't know it. So we know
Yes,
that by
sir.
the time we get the root mean square current, we can get this. Then multiply by 120. So the root mean square current is equal to 200 divided by 120. So what will this give us? What? Sorry, this thing is 2000, not 200.
Okay, sir.
It's 2000 watts. Okay, so we have 200 divided by 12. So what do you have as from your calculator, please? What's the answer? Hmm? Is it? Which bag? I already see the drink. Nobody with calculator? 200 divided by 12. So you have 16.67. So let me just say 16.7 ampere. So if this is what I have for my root mean square current, then my peak current is going to be, sorry, then I have to recall that root mean square current is equal to peak current divided by what? Root 2. So the peak current is going to be root 2 times 16.7. So I naught is going to give us 23.6 ampere. So have you seen that now? So we've gotten our peak current now. Then we have to find our resistance. So if we are looking for our resistance, we know that root mean voltage is equal to root mean square current times resistance from Ohm's law. Abi, V is equal to
Yes,
IR.
sir.
So this is going to be 200 to equal to 16.7 times resistance. So the resistance is now 200 divided by 16.7. So what do we have? 200 divided by
200.
16.7.
Yes.
That's 11.9. Is that correct?
11.9. Yes, sir.
A mistake somewhere. Our root mean square voltage is not 200, it's 120. So this is 120. So 120 divided by 16.7. That's 7.2.
Yes, sir.
So 7.2 ohms. And that's going to be the results. Do you understand that now?
Yes, sir.
So let's calculate for the second part of the question. That's the B part of the question. So the B part of the question says calculate the power if the voltage was doubled. So if the voltage was doubled, that means we are going to be having, instead of 120, so that is double. So 120 times 2, that's 240 volts. Abi? So our power is going to be V square root mean square all over R, or root mean square I multiplied by R. So either of the two, anyone you're okay with. But it's not advisable to use this because we are told that the voltage has doubled. Are you following? Oh, seems. Are you following now? We cannot
Yeah,
use
yeah.
this. We can't use this because if you use this, the current that we have for this is 120. That is, we have the current that we if you use this I right now, the voltage that we use to generate the current is 120. But now the examiners want us to use what? 240 voltage to generate what? The power. So we have that. The power is going to be 240 volts all square divided by the resistance. Since we are assuming that the resistance is constant, so that will be 7.2. So we have 800 watts to be our result, and that's the power. Now I want you to look at something. When you double the voltage, because these are some kind of questions that examiner would like to ask you, or that they usually ask, that when you double the voltage, what will happen to the power? So if you double the voltage, assume that what? The resistance is constant. The power is going to be what? Quadruple. Are you getting where I'm coming from now? So, Abi, am I right with this? Is it 8,800? So let me check. 240 times 240 divided by 7.2. That's 8,000 watts. So if you double the voltage, the power is going to be 4 times the original value. So let's take a look at another question. And that's question number 2. So the question says the harm standard the arms standard line voltage the arm standard line voltage is 120 volts in a typical household. In a typical household, calculate the peak voltage. Calculate the peak voltage. So, as usual, the first thing we do is to read the question to ourselves. The arm standard line voltage is 120 volts. That means the root mean square voltage is 120 volts in a typical household. Calculate the peak voltage. So we are looking for the peak voltage. So we have to find the relationship between these two. Root mean square. Hey, if you want to talk, you go to the other room. I'm in class. So the root mean square voltage is V naught divided by the square root of 2. And that's equal to 120 So if this is the formula, so we have that 120 is equal to V naught all over root 2. So V naught is 120 times root 2. And when you press your calculator, that should give us approximately, 167. That should give us 169.7 volts. So the peak voltage is approximately 170 volts. So I hope we get this now. Okay, since the network is really disturbing people. So let's go to the next question. That is question number 3. So for question number 3, we have that Consider the sinusoidal. Consider the sinusoidal function. Consider the sinusoidal function shown below. Calculate the root mean square current. Calculate the root mean square current. So this is the sinusoidal. So this is time, and the peak value here is 10 ampere, and here is negative 10 ampere. So this one now, we are given the question that consider the sinusoidal function shown below. Calculate the root mean square current. So what's the root mean square current? We have that I peak, that is the peak value of I, is 10 ampere, and we are looking for the root mean square current. So root mean square current is equal to I naught all over root 2. So that's 10 divided by root 2. So we can just multiply both numerator and denominator by 2. So we have that the root mean square current is equal to 10 root 2. Root 2 times root 2 will give us 2, and that will be 5 root 2 ampere. So that will give us the root mean square current that we are looking for. And if you want to put your answer in decimal, then you can just press your calculator, 5 root 2, and you have your result. So we'll go to question number 4. So question number 4 states that a 200 watt laptop is connected to a 240 volt AC line. To a 240 volt AC line. A, calculate the root mean square. Calculate the root mean square current. Calculate the root mean square current flowing from the outlet. Then B, determine the peak current calculate the peak current, and C, calculate the peak voltage. And D, calculate the maximum power delivered. From the AC line. All right. So here's the question we have right here. So let me put down solution. We are told that a 200 watt laptop is connected to a 240 AC line. The question says calculate the root mean square current flowing from the outlet. B, determine the peak current. C, calculate the peak voltage. And D, calculate the maximum power dissipated or the maximum power delivered. So what are we going to do? So the very first thing to do is to read the question to ourselves and then write out the parameters in the questions. So we have that a 200-watt laptop. So the power is 200 watt connected to a 240 volts. So the root mean square voltage is 240 volts. Calculate the root mean square current flowing from the outlet. So for option A, we are looking for the root mean square current. So the very first question to ask is, what are the relationship between power, root mean square voltage, and root mean square current? Remember, this is the average power dissipated. So we have that average power dissipated is root mean square current times root mean square voltage. So the root mean square current that we are looking for will now be 200 divided by 240. And that should give us 2 here 10 and 2 here 12. So that's 10 over 12. So if we press a calculator, our result should be 0.833 in ampere. So we've solved for A now. Now we'll go to B, where the question says determine the peak current. So for us to get the peak current, we know that the root mean square current is equal to the peak current divided by root 2. And that implies that the root mean current, which is 0.833, multiplied by root 2 will give us the peak current. So the peak current is going to be, when you multiply these two together, you have 1.1785 in ampere. So we'll go to the C part of the question. So there's nothing to this topic, absolutely. It's a very simple topic, but it can be scary. So calculate the peak voltage the same way. Root mean square voltage is equal to peak voltage all over root 2, and that implies that the peak voltage is equal to the root mean square current, the root mean square voltage multiplied by root 2. So we have that the peak voltage is equal to 240 multiplied by root 2. So if you have 240 multiplied by root 2, that will give us 339.4 volts. And that gives us answer to that. And if you go to the D now, which is the last part of the question, we are asked to calculate for the maximum power dissipated. Now, for you to get the maximum power, there's need for you to understand that maximum power is going to be the peak current times the peak voltage. And at the beginning of the class, I told you that you need to solve more questions. The more questions you solve, the better you become. Now, in the class, when I was explaining the topic, I did not mention maximum power. But you see now, from the question we have at hand, the question asks us to calculate for maximum power. So how do we know that? So we know that the peak current times the peak voltage will give us what? The maximum power. If the root mean current times the root mean voltage can give us the average power, then the peak times peak should also give us what? The maximum power. And that will be the peak current is 1.1785 times the peak voltage, that's 339.4. And if you multiply all of this together, you have 400 watts. And this makes sense. And why do I say it makes sense? Is because when you look at the average power given to us, the average power is equal to what? 200 watts. And the maximum power is equal to 400 watts. So we can create a shortcut from here and say that the maximum power is 2 times the average power. Or we can say that the maximum power is equal to 2 times root mean square current times root mean square voltage. So this will give us what? Maximum power. And average power is 1 over 2 of the maximum power. So that solved the questions. So let's go a little bit upward before we start considering the other area of this topic. So question number 5, the question says that a root mean square current, of 5 ampere flows through a 10 ohms resistor. Full stop. A, calculates the average power absorbed by the resistor. Then B, calculates the peak voltage across the resistor. Now guys, whenever you are given this kind of a question, should in case if you are A-level student here or you are a WAEC student, the best way to attempt this question is to start with a diagram. Am I making sense now? So when you read the question to yourself that a root mean square current of 5 ampere flows through a 10 ohms resistor. A, calculate the average power absorbed by the resistor. And then B, calculate the peak voltage across the resistor. So the first thing you want to do is to make a sketch of your diagram. So let's have this. Sorry. Okay. So since it is AC, instead of battery here, I'm going to put the AC signal here. So we have this. And we are told that the current that flows through is 5 ampere. That's the current. And the resistor is 10 ohms. So calculate the average power absorbed by the resistor. So we have that average power is equal to the root mean square current times the root mean square voltage. Now, what's the root mean square current? The root mean square current here is 5 ampere. Am I making sense now? So, and what about the voltage? We don't know the voltage. So, what we are going to do is to recall that V is equal to IR. So, if this V rather is root mean square V, then this I also will be root mean square I. Therefore, the average power we are looking for is going to be I square, that is root mean square I, then times resistance. Therefore, you have that average power is equal to, what's our I? 5 ampere. So we have 5 ampere square multiplied by, what's our R? 10. So the average power absorbed by the resistor is going to be 25 ampere times 10, and that means times 10 ohms rather, yeah. And that means our result is going to be 250 ampere square ohms. So if you don't want to write it like this, you can use the standard unit of saying what? 250 watts. Do you understand that now? So that's the average power dissipated. So what's the second question? Question B, part of it, says that you should calculate what? Calculate the peak voltage across the resistor. So we're looking for the peak voltage across the resistor. So we know that the root mean square voltage is equal to the root mean square current times resistor. So the root mean square voltage is therefore going to be what? Our I, which is 5, multiplied by the resistor, which is 10. So the root mean square voltage is going to be 50 volts. So if this is 50 volts, then we can find what? The peak voltage, which is equal to root 2 times the root mean square voltage. Therefore, you have that the peak voltage is 50 multiplied by root 2. So V naught is 50 root 2 volts. Or you can convert it to decimal. And if you do that, you are going to have 70.7 volts. I hope you understand this now. So let's move to question number 6. You still have more questions here. So let's go to question number 6. The question states that the current I in an AC circuit is given by the equation I equal 30 sine omega t, 30 sine 100 pi t, where t is the time in seconds. Deduce the following from this equation. Deduce the following from this equation. A, frequency of the current. Frequency of the current. B, peak value of the current. Peak value of the current. And C, the root mean square. The root mean square value of the current. All right. So how do we answer this question? Is Mr. Pedepirasi there?
Yeah, I'm here. I'm here.
Okay. Hope you are getting it. Now, for us to put solution to this question, we have that let me read the question. The current I in an AC circuit is given by the equation. So this is the instantaneous current and is given as 30 sine 100 pi t. So the question says we should deduce the first one, the frequency of the current. So what are we going to do? The best thing to do for us right now is to compare the equation. So the original equation is given as I equal I naught sine 2 pi f t. So by comparing coefficients, that means we have that 30 sine into brackets 100 pi t is equal to I naught sine 2 pi ft. Graph. So I naught, which is the peak current, is going to be 30. No stress. Then 2 pi, that will be 100 pi t is equal to 2 pi ft. Pi we cancel pi, t we cancel t. So we have that. So we're going to have that. So we have I naught to equal 30 ampere. And by the time you divide both sides by 2, F is equal to 100 over 2. And that will give us 50 hertz. And that's so simple. So the next question now states that calculate the root mean square value for the current. So to get the root mean square value for the current, that's quite easy. So we are going to have that the root mean square current is I naught divided by root 2. That will be 30 divided by root 2. So let's multiply both numerator and denominator by root 2. And that will give us 30 root 2 over 2. So the root mean square current is equal to 15 root 2. So I hope you get this now. So that will be in ampere also. And you can convert it to decimal. So anyone that you find convenient, you can do. So that's that about that. So let's go to question number 7. Okay. So I think this question number 7 is purely JAMB. The one we have been solving since are from WAEC past questions. Hold on, please. Some people are saying they can't join. Okay. All right. So question number 7 now. The question says the current through a resistor what happened? The current through a resistor So the current through a resistor in an AC. Yeah? Go and take one crochet first. You climb chair on the fridge. Take one crochet, then you come with a cup. Daddy. Do what I ask you. The current through a resistor in an AC circuit is given as 2 sine omega t. 2 sine omega t. Determine the DC equivalent. You can see what I'm saying here. So determine the DC equivalent of the current. So A equal 1 over root 2 ampere, and option B is 2 root 2 ampere, option C is 2 ampere, and option D root 2 ampere. So how do we go about this? The current through a resistor in an AC circuit is given as 2 sine omega t. So that means I instantaneous current is equal to 2 sine omega t. And normally, instantaneous current is given as peak current sine omega t, right? So if you compare coefficients, we have that the peak current is equal to what? 2 ampere. So if the peak current is equal to 2 ampere, then we have that the equivalent, the DC equivalent current that we are looking for is the same thing as the root mean square current. That will now be I naught over root 2, and that will just give us 2 over root 2. So we don't have this in the option, right? So there's something else we can do. We can just rationalize the denominator. So we have 2 root 2 over 2 aboki pamala. So we have root 2 over A, and that's option D. So it's quite simple. So example 8. Okay. So let's look at example 8, and probably when we check example 9, we can stop there, then take a break, and when we come back, we just continue from reactance and impedance. Or we take opinion on that other one that I just mentioned now. So question 8, the question says that in an AC circuit, yeah, the peak value, where's the content? Sorry, please. Check on the fridge and pick that thing that looks like bread. You pick 2 or 3. Use the chair to climb. Sorry, please. In an AC circuit, the peak value of the potential difference, the peak value of the potential difference is 180 volts. Full stop. What is the instantaneous potential difference? when it has reached 1/8 of a circle. That's 1/8 of a circle. You go and bring another cup for me. Sorry, please. Oh. The whole of the house are hungry. Okay. Solution. Now, when you look at this question here, we have that in an AC circuit, the peak value of the potential difference is 180 volts. What is the instantaneous potential difference when it has reached 1/8 of a circle? So this is quite simple, and what we just need to understand is this. When I say 1/8, let's start from here. We have that in an AC cycle, the peak value of the potential difference is 1. So we have that V naught is 180 volts. So if V naught is 180 volts, what's the next thing? What is the instantaneous? So we are looking for V. And if you recall, instantaneous voltage is equal to V naught sine omega t. Abi? And we said that omega t is the same thing as theta. Abi? I just use phi here, which is it can be the same thing. Now, how do we go about this? How do we know the value of this theta? Because right now, we should have just calculated our answer directly, since we have V naught already 180, but we don't know this angle, right? Now, let's go back to the question. The question says, what is the instantaneous potential difference when it has reached 1/8 of a circle? What are they telling you here? Is that if I have a circle like this, and I divide the circle into 8. Sorry, let me divide it well so that you understand what I'm showing. Okay. So let's say this is a circle now. So if this, are we together?
Yes, sir.
So if this is a circle, we want to understand this question now. If I divide this circle into 8 different parts, 8 equal parts, so if you look at this now, let's say all these parts are equal now. This is 1, 2, 3, 4, 5, 6, 7, 8. I seen it now. Let's say this is the starting point. This is the origin, the starting point now. So if the question says, what is the instantaneous voltage when it reaches 1/8 of the circle, right? This is the entire circle. 1/8 of the circle is within here to this place. Are you getting it now? Since everything is equal, from here to this place, we need to know the value of this angle. So how will I know the value of this angle? It's very simple as well. If you look at the entire circle, how many angles do we have in a circle? How many angles do we have in a circle? I'll give it to you. What's the total angle in a circle? And this is your own. Anybody helping?
360.
Thank you, sir. 360. So the total angle in a circle is 360. So if this circle is divided into 8, each of the angle is going to be what? 360 divided by 8, and that's 45 degrees, if I'm not mistaken. Is that 45? I guess. Therefore, the instantaneous voltage is going to be 180 sine 45. So what's the value for sine 45? Is that not 2 root 2? So the instantaneous voltage will be what? 360 divided by root 2. So multiply both sides by root 2. Then we have that the instantaneous voltage is 360 root 2 over 2. Therefore, the instantaneous voltage is 180 root 2 volts. So any question on that? Is it 180? Yeah. Am I right with that? Please, oh, something is wrong. My angle is wrong. I think it is root 2. Yeah, I think it's root 2 over 2, not 2 over root 2. So V is equal to 180 sine 45 degree, and that's 180 multiplied by root 2 over 2. 2 here 1, and 2 here is what? 90. So we have 90 root 2 volts. Please, do you understand how we solve this now?
Yes, sir.
So that's why I said that the success of anything you are learning in physics lies on the time you have to solve questions. So let's look at this last example. Example 9. The instantaneous value of the induced EMF as a function of time is epsilon equal epsilon naught sine omega t, where epsilon naught is the peak value of the EMF. Full stop. The instantaneous value of the EMF, we all know what we call EMF, right?
Yes, sir.
Of the EMF, 1/4 of the period is A E naught over 4, B E naught, C 0, and D E naught over 2. So can you try this? Now, let's see if we have that epsilon is equal to epsilon naught sine omega t. And we have to find the instantaneous what? EMF. When what? At 1/4 of the circle. So 1/4 of the circle means you have a circle and you divide it into what? 4. So what's each angle going to be? So this an angle, this is another one, this is another one, and this is another one. So that means this is 90, 90, 90, 90. Abi? That means omega t is equal to 90 degrees. Are you following us?
Yes, sir.
So if this should be the case now, then I will have that epsilon is equal to epsilon naught sine 90 degree. So epsilon is equal to epsilon naught because sine 90 degree is what? 1. So the correct answer is what? B. So what was your mistake?
I kept I didn't do sine 90.
So where do you not get 2 from? How did you solve it before? Hello?
Hello, sir.
How do you solve it? How do you solve it?
I just did
I'm listening. You just did M and that's all. Because the essence of the class you are is to get it right, not for you to be guessing. You don't want to guess your answer. You want to do something. That thing you want to do is what you understand. So either you get it right or wrong, it doesn't matter. As long as you understand what you did. Once you understand what you did,
okay, sir.
and we make a correction, you'll be able to know where you are at fault so that you can fix it. But if you are guessing in class, it doesn't work that way. The idea
Okay,
is not
sir.
the idea is not for you to get the right answer. The idea is for you to what? Do what you understand. Then we'll be able to tell if you have gotten it right or wrong. So if you have not gotten it right, we know what you are missing. Then it will be fixed. Because if you don't make a mistake and somebody is making correction, it's just a waste of time because there's nothing wrong initially.
Okay, sir.
So I hope you understand this now.
Yes, sir.
Because these are JAMB questions, so that's why I'm emphasizing on it. You can see the way JAMB we ask their own question is quite different from the way WAEC we ask. WAEC will be direct because it will take more of your time. But JAMB, it is a simple question. For that reason, they will not want to come direct. They will come from the point of if you have understand it very well, you know that this is what you are talking about. For example, look at the terminologies they are using. The whole of the question we have been solving from number 1 to number 5, you get to see that they are using direct terms like find the root mean square, find the peak value, find the peak voltage, find the peak current, they are using direct language. But check from example 6 downward, they are not using direct what language anymore. Find the what DC equivalent current. Instead of them to say find the root mean square, they are asking to find what DC equivalent. Instead of you to find what the voltage or find what the current, they tell you find the instantaneous current. So they are the one that utilize all these what terminologies that I once explained before. That's what make their exam look tricky. So if you don't understand it very well as a teacher, you'll be like, where is this one coming from? What does this mean? I hope it's
Okay,
clear.
sir. Yes, sir.
So let let me take our opinion. We have like two to three more two more okay, two more areas to go, and that's the area of reactance and impedance, then resonance. Reactance, impedance, and resonance frequency. So my question is, should we go for break and then come back by 1 o'clock and continue the class to finish it up, or we should meet on Thursday to finish it up while we go and practice the whole of the ones we've covered in today's class? So your opinion is needed.
Sir, please, I don't know, but sir, please, let's continue on Thursday. First of all, my phone is low, and and then I have to learn the ones you taught us today, so I'll be able to know if I really understand them. Cause I was missing the class halfway, cause my phone went off, and then my data ran low. So
Oh, Mr. Adepiga, what do you think, sir?
It's okay. Fine. It's okay.
We should continue on Thursday, right?
Yeah, what time on
yes,
Thursday?
sir.
It should be the same time.
Except the class will be recorded. Me, I have class on that Thursday.
Oh, what time do you have class?
In the morning. I have class from 8 on Thursday till around 3 p.m. It's a very hectic day for me.
Ah, and you lecturers,
We are
Abi.
starting exam now. They are preparing. Last week, we are starting exam. They
Oh,
won't do test on Monday.
okay.
So Monday, so we have to take revision for everybody. And, getting stressful. But the class will be recorded. If the
Yeah,
class is
sure.
recorded, it's fine.
Sure.
There is no problem. Yes.
Okay.
So that
What's it
if
called?
everybody will be available that Thursday, if it's only me that will not be available, the class can be recorded. I will get the concept. That's why.
All right, sir. But this one is clear. Now you can pick all those, like you can start putting those teachers through now, sir.
Is that I leave me? I beg you.
Because I know that's the
You know,
motive
I've
of
always
that's the
the
motive
problem
of
I
you
have
being
with
here.
this.
It's not as if probably you need physics help from anywhere.
The problem, I just know something. I've seen a lot of Jambite complain about this very particular. If you tell a Jambite to tell you physics, three physics topic, they don't understand at all. I have done my analysis and I saw this topic is always there.
Exactly. And if
It's always there.
and if you look at it, there's nothing difficult in it now. Is that not what we just brush?
Hello. Ẹ̀yin tẹ́ lọ ka physics, Ọlọ́run máa ṣàánú gbogbo àwọn physics teacher.
So
It's crystal clear. The concept is crystal clear. It's clear.
as in there is
Very
nothing in the topic. I don't just the problem that teachers have is that they just go and read textbooks. They don't understand textbooks.
that's the point. That's just the point. And they
And
begin to solve some example, the same example from the textbook. Give them one example outside the textbook, there will be wahala.
that's just it. Because in the
That's a
textbooks,
problem.
the topics were just scattered because they don't know what to explain. They have to put it together. There's no story. It was just
God will
graph,
forgive
graph,
me.
graph, graph. So for you to make it interesting, you have to understand those graphs.
And even the introduction to the topic is important. You don't just come and be saying pick mean square, remove mean square. You are just scattering everything. The
That's it.
introduction to the topic
Exactly. You nailed it.
is important. You are teaching
Exactly.
an AC or DC. It's not the equation that should come first. The introduction to the topic to know what is the application. Okay,
Exactly.
the reason why you are using the root mean square, they cannot charge you this, they cannot charge. These are simple concepts they need to learn. You just come and be saying
Exactly.
root mean square. Oh yeah, why is there a root mean square? That is the textbook now. Have you not been reading your textbook?
So
Okay.
all of those things are what we just need to like work on. We just
Yeah,
we got it
that's
covered.
just the problem I noticed. We
Yeah.
have a lot of them. Maybe pressure. I think some of them, laziness is one of the things too that is their problem.
Is a
Because if
huge
you don't know this
factor.
thing too, reaching out to somebody that knows it and paying for knowledge is a Nigerian teacher problem.
Seriously. We don't want to
They
pay
they
for that
pre-
knowledge. We don't want to
at
pay for that
all. When
time.
they hear there is a money involved as a teacher, they feel too like wait, which money I want pay for this thing? Which money do I want to pay? Which
See?
money I want pay for about what I've been teaching for 6 years? Oh guy, you don't know it. It's not a matter of the year. You don't know it. Okay, go and learn it. So I think that's the problem. We want to. I was speaking to some set of teachers yesterday in last week, in secondary school. I said this is a place where you people want to earn a whole lot, but you don't want to do a whole lot.
That's it. That's it.
You are asking for increment in salary, and you know that the knowledge you are dissipating is not standard.
You're not making any
You don't need
effort
to
to
act.
improve on what you know before.
You
Like
don't need to act.
the
I
same way
told
you
somebody
teach this topic this year
I
is
have
the same way you
paid a
want.
colleague.
Yeah.
The guy organized a chemistry class. In fact, when I paid the money, he returned it. I said, no, it's not a matter of I want to be part. There will be something you will be saying that probably have not had before because you're a chemistry teacher and I know you are good. So me paying for the class. He said, Mr. John, like I said, I want to pay. Is it not my money? It's my money, Oga. Let me
That's it,
pay.
man.
In fact, the guy said no, that I should join the class. And I said no. The same amount you are charging is the same I will pay. These things are how you discipline and train yourself as a teacher to wanting to pay for knowledge. Knowledge is not
Exactly.
free. Go everything over there free.
I can
And
remember
even the guy,
when I was taking my I think I always pay £8.50 every month
hmm,
for this guy, organic chemistry.
okay. Yeah, orí yẹn pé o.
I pay the guy £8.50 every month.
Imagine, imagine.
So
So for class,
yes.
there are
So
knowledge. You need to pay for it. If you want to be exceptional, you need to pay for knowledge.
oh
That's the
no,
problem.
they are just
That's
is
the
the
problem.
students that I'm feeling for, they're just ruining the life of those students, the ones that are
That's the
serious that want to learn among them, you know,
that's the
they don't get that
that's
quality.
the,
I just
that's
Josephine,
the I hope you two will resume YouTube soon. So
I'll
Yes, sir.
resume soon. I'll resume soon.
okay, can you see? Josephine is saying yes, sir. Mr.
Josephine, please
Privilege,
check
resume
out this
YouTube.
on YouTube. Chemistry Hangouts.
Sir?
I said you should check out this page on YouTube.
Okay, sir.
Chemistry Hangouts.
Okay, sir.
And you can also check Maths Physics Hub.
Math what?
Maths, let me write it here. Can you see? Maths
Yes.
Physics Hub. Together. Physics Hub is together.
Okay, sir.
Yeah. So those two channels will prepare you well for JAMB. Till we meet on Thursday again by God's grace.
Okay, sir.
I think we
Thank you,
even
sir.
see how
You're
what I
welcome.
pay as you need video